Welcome to the session on the binomial expansion, binomial problem solving. The objectives for this session are to find individual coefficients in a binomial expansion. The general term of the binomial expansion can be used to find individual terms in a binomial expansion. In the expansion of a plus b, all raised to the power n, the general term is given by n choose r times a to the power n minus r times b to the power r. And here we have n choose r is equal to n factorial over r factorial times n minus r factorial. Recall that n factorial is equal to n times n minus 1 times all the way down to times 3 times 2 times 1, and 0 factorial is equal to 1. Let's have a look at an example to illustrate this. Find the coefficient of x cubed in the binomial expansion of 2 plus 5x all raised to the power 8. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. The x cubed term is 8 choose 3 times 2 to the power 8 minus 3 times 5x all raised to the power 3. Here we substitute n equals 8, r equals 3, a equals 2, and b equals 5x. And of course, 8 choose 3 is 8 factorial all over 3 factorial times 8 minus 3 factorial times 2 to the 5 times 5 cubed times x cubed. Of course, we can now tidy up a little bit. The 6 cancels with the 3 factorial because 3 factorial is 3 times 2 times 1. And the 5 factorials cancel. And 8 times 7 times 2 to the 5 times 5 cubed becomes 224,000. And of course, x cubed remains as it is. And hence the coefficient of x cubed is 224,000. Now let's have a go at another example. Find the coefficient of x cubed in the binomial expansion of 3 plus x times 2 minus 5x all raised to the power 6. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Now the first 4 terms of 2 minus 5x all raised to the power 6 are given on your screen. We have a equals 2 here. We've simply plugged this in into the general term of for the formula. And b equals minus 5x here. Again, we've simply plugged in. N equals 6 here. And the various values of r here. And then tidying up gives us 2 to the 6 plus the x term plus the x squared term plus the x cubed term, and so on. And then tidying up some more, we have 64 minus 960x plus 6,000x squared minus 20,000x cubed, and so on. Now we can expand 3 plus x times 2 minus 5x to the power 6 in order to find the x cubed term for the entire expression. So let's expand this. We only require the first 4 terms in the expansion of 2 minus 5x to the power 6. And we'll explain why in a moment, because notice we're multiplying by 3 plus x. There are 2 ways of making the x cubed term in this expression. Either we multiply the constant by the x cubed term, or we multiply the x term in 3 plus x by the x squared term in the expansion. The constant times the x cubed term is 3 times minus 20,000 x cubed, and the x term times the x squared term is x times 6,000 x squared. So putting those together gives us that the x cubed term is 3 times minus 20,000 x cubed plus x times 6,000 x squared, giving us minus 54,000 x cubed. So the coefficient of x cubed in the binomial expansion of 3 plus x times 2 minus 5x to the power 6 is minus 54,000. As shown. We will now have a go at another example. Now f of x equals 1 plus kx all raised to the power 9, where k is a constant. Find the value of k given that the coefficient of x to the 5 in the binomial expansion of f of x is 4032. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. The x to the 5th term is 9 choose 5 times 1 to the power 9 minus 5 times kx all raised to the power 5. We've simply input into this general term formula. So 9 choose 5 is 9 factorial all over 5 factorial times 9 minus 5 factorial. And of course here's 1 to the 4. Kx to the power 5 is k to the 5 times x to the 5. And then we start the cancellation process. So we're going to express 9 factorial as shown. And we've done that so that we can cancel with the 5 factorial below. And of course 9 minus 5 factorial is 4 factorial. And here we have k to the 5 times x to the 5. So this tidies up to 126 times k to the 5 times x to the 5. And of course, as given in the question, the coefficient of x to the 5 is 4032. So we can now start to calculate or find the value of k to the power 5. So 126 times k to the power 5 is equal to 4032. And so rearranging gives us k to the power 5 is 4032 divided by 126, which is equal to 32. Therefore, fifth rooting this gives us that k is equal to 2. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's take a look at example 4a first. Write down the first 4 terms in ascending powers of x of the binomial expansion of 1 plus qx all raised to the power 10, where q is a non-zero constant. So let's solve this. We're going to look at the first four terms of 1 plus qx all raised to the power 10. Here's the first term, the constant, 1 to the power 10. Here's the x term. We've simply substituted the values into the formula for the general term. And again, the x squared term, the x cubed term, and the x to the fourth term. Notice that here n is equal to 10 and r is increasing progressively from 1 all the way up to 4. And now tidying up, we have 1 plus the x term plus the x squared term, the x cubed term, and the x to the power 4 term. And then tidying up some more, we have the first four terms in ascending powers of x of the binomial expansion of 1 plus qx all raised to the power 10 as required. Now let's have a go at example 4b. Given that in the expansion of 1 plus qx all raised to the power 10, the coefficient of x cubed is 108 times the coefficient of x, find the value of q. So from part A, the first four terms of 1 plus qx to the power 10 are given as shown. The question informs us that the coefficient of x cubed is 108 times the coefficient of x. So let's put that into an equation. We have that the coefficient of x is 10q and the coefficient of x cubed is 120q cubed. And since we have that the coefficient of x cubed is 108 times the coefficient of x, we have 120q cubed is equal to 108 times 10q. And so tidying up this equation, gives us that q squared is equal to 9. And therefore q is equal to plus or minus 3. This brings us to the end of this session. If you have understood its contents, you should be able to find individual coefficients in a binomial expansion. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.